In this video, we're going to talk about, let me get things together, marginal cost and marginal revenue, right? And so what we've been dealing with was previously was a cost function that looks like this, right? Cost function had a fixed cost, was given or plotted here, and then we had a constant slope, which meant we had a linear cost function. And that linear cost function was given by this equation here. C of Q, which is your cost as a function of the quantity of items you produce, equals your fixed cost plus M times Q. Remember, M was your slope and Q is your quantity of items. Multiply those two things, and that gives you your variable cost of producing items. All right. Well, that's in the linear cost function, right? Sometimes cost functions look something like this. There still may be a fixed cost, which is given by your vertical intercept. But as this statement says, sometimes the cost function increases quickly at first and then more slowly because producing larger quantities of a good is usually more efficient than producing smaller quantities. This is called economy of scale, right? So I may have sort of what seems to be a linear relationship between the cost and the quantity of items for a little bit of items being produced. But as we mass produce things, sometimes, you go to a factory and they can mass produce your items that you're producing, then the cost is more effective, right? And so sometimes our cost function may kind of bottom out or, flatten out a little bit. And then later it may go and start to increase because when you produce too many, that cost efficientness of the producing the mass quantity of products may be lost, right? And so it says at still higher production levels, the cost function increases faster again as resources become scarce. Sharp increases may occur when new factories have to be built and things of that nature. So that's why we may have this uptick again or that increase in the rate of change in your cost function. But in either case, cost is still your fixed cost plus your variable cost, but sometimes we may not have a linear function. We may have a nonlinear cost function, all right? The same thing happens for revenue, right? Revenue equals price times quantity, right? P is the price per item that you're selling your item, and then Q is the quantity of items. And so we have this written as a function of quantity. It says there may be some non-linear revenue functions, and it says for large values of Q, the market may become saturated, causing the price to drop. And when the price drops, you're not going to get as much per item as you were originally. And so that's why we may have a non-linear cost function. Especially it becomes non-linear as we get more and more items being sold on our market, right? And so we have to start thinking about cost of revenue as a non-linear function instead of just linear functions, which means our profit will also be nonlinear functions. All right. And so we're going to review some of the things that we've done before, but looking at nonlinear functions. And then we're going to bring our derivative into play so that it can help us make economic decisions. In example one, it says if C is the cost and R is the revenue that are given in the graph below, for what production quantities does the firm make a profit, right? And so my cost function is this function here. It's the curvy function, right? Cost is close to this endpoint right here, and that's this curve here. And revenue is close to this endpoint here, and that's that straight line here, right? And so remember, profit equals I'm not going to use the words. I'm going to use the symbol. Remember that we use the symbol pi for profit. So pi of Q equals your revenue minus your cost. And so if I'm looking at the graph and I want to determine what production quantities does the firm make a profit, you make a profit when profit is greater than zero, right? That means when revenue is greater than cost, right? So if I were to switch this equation, right, we have this inequality. We want that to be greater than zero, then that means R of Q has to be greater than C of Q if I added C of Q to both sides, right? And so when I'm looking at a graph, if I want to know where my company is making a profit, look where my revenue function has higher Y values than my cost function, right? Well, from here to this point right here, right, cost is greater than revenue, right? So I'm going to call this Q1. But after Q1, My revenue function is which is that straight line, is above my cost function, which is this curve right here, all the way until I get to this point right here. I'm going to call that Q2, right? And so if I want to say what production quantities does my firm make a profit, I would say between Q1 and Q2, right? Remember, Q1, that is called your break even point. That's the point at which you start to make a profit. Here, you're at a loss. Here, you're at a profit. And if you produce and sell too many items, you're going to get back at a loss because the cost is going to uptick too much, right? And so we always want to be in this area here so that our company is making a profit, right? Some economic decisions are going to depend on what we call marginal cost and marginal revenue. We talked about these before, but now we're going to really get into marginal cost and marginal revenue. Marginal cost, which is sometimes given by MC, that's the rate of change of your cost function. Since your derivative represents a rate of change, we can use MC, or we can use C prime of Q, or we could use dC dQ, which is our Leibniz notation. There are ways that we can interpret. I'm going to interpret this in one way. I'm going to say that your marginal cost is the additional cost of increasing production from Q items to Q plus 1 items. All right. Remember, our slope is the change in Y, or your output, for 1 unit change in your input, right? And so if I have Q items and I want to interpret C prime of Q, well, when I increase Q to Q plus 1, that's the additional cost of increasing that production from Q to Q plus 1. All right. The marginal revenue, which sometimes is given by the notation MR, that's the rate of change of your revenue function, right? And so, it's the rate of change of your revenue function, which is R of Q. And of course, a rate of change is the same thing as your derivative function. And so it's denoted R prime of Q. And in Leibniz notation is dr dq. The interpretation of that is very similar to the interpretation of your marginal cost. It's the additional revenue from selling, because revenue comes from selling, from increasing sales from Q items to Q plus 1 item. So it's the additional revenue. Again, we're using that slope, 1 unit change in your input. It tells you how much your output is going to change, right? And so if I increase my sales from Q to Q plus 1 items, that's how much I expect my revenue to increase or change, all right? And so let's look at some examples where we apply marginal cost and marginal revenue. In this example, I have my cost function. So this is C of Q. It's asking me to determine if the marginal cost is greater at Q equals 20 or Q equals 40, right? So remember, marginal cost, I want to say basically, is C prime of 20 greater than C prime of 40, or is C prime of 40 greater than C prime of 20, right? When I see a derivative, I should automatically think slope of a tangent line, especially when I see a graph. And so what I'm going to do is I'm going to draw my tangent line at 20. I'm going to put it in red. My point on my cost function is that point there. My tangent line looks something like that, right? At 40, my point where my graph has an input value of 40 looks like that. And my tangent line looks something like that, right? And so the derivative is steeper, is greater for the point that's steeper, right? And so since this is positive, that's positive, we only need to know which one is steeper. And since 20 is less steep than 20 at Q equals 40, I know that C prime of 40, the marginal revenue at Q equals 40 is greater than the marginal revenue at Q equals 20. So I'm going to say at Q equals 20. That's my answer. All right. And so that's using the slope of the tangent line because the derivative is the same thing as the slope of the tangent line. Let's look at another example. It says for Q units of products, of a product, a manufacturer's cost is C of Q dollars and the revenue is R of Q dollars, with C of 500 equals 7,200, R of 500 equals 9,400. Marginal cost at 500 is 15 and the marginal revenue at 500 is 20, right? So we have stuff about the cost and revenue as well as marginal cost and marginal revenue at Q equals 500 quantities of items. All right, and so we want to know what is the profit or loss at Q equals 500. Well, anytime we're talking about profit, remember profit is the same thing, and it's at 500 as your revenue evaluated at that value minus your cost evaluated for that number of items, right? And so R of 500 is 9,400 and C of 500 is 7,200. And so if I do 9,400 minus 7,200, I'm going to get, I believe, 2,200. All right. And so that's my dollars, and that is profit because that is positive. If that were negative, I would say we're at a loss of $2,200, right? But it's a positive value. Okay. In part B, it says if production is increased from 500 to 501 units by approximately how much does the profit change? Now I've got to be careful here. I'm changing from 500 to 501 units, right? That's it. So if that means if I increase my input, my quantity by one item, it's asking me how much my profit is going to change. The fact that that's one item, that should ring in my head. I need to think about a derivative or a slope, right? And so this is basically asking me what is pi prime of 500? Right? Because it's going to give me, I want to know the change in profit for 1 unit change from 500 to 501 items, 1 unit change in my input, right? Well, if I want to find pi prime of 500, remember, pi of 500 equals R of 500 minus C of 500. And so the derivative, pi prime of 500, is going to be R prime of 500 minus C prime of 500. All right. So all I have to do is get the marginal revenue and subtract the marginal cost, and that's the marginal profit. So this, although I didn't define that, this is basically asking about marginal profit. How much will the profit change for 1 unit increase in your input or your quantity of items that you produce and sell, right? And so we're given the marginal cost and marginal revenue. The marginal cost is 15, the marginal revenue is 20, right? And so they use MR, I'm using R prime. They're the same thing, different notation, right? And so that's 20 minus 15. 20 minus 15 is 5. And that's going to be dollars per unit. All right, because 500 to 501 units. Some people may say items, but this says units in this example. All right, so if you want to know your marginal profit, it's just your marginal revenue minus your marginal cost. All right, with this, now that we're getting used to the marginal revenue and the marginal cost, and now we know marginal profit, we can talk about decision making for companies. For instance, it says having information about cost and revenue can help companies determine where they should increase production levels to increase profit. All right. I'm going to focus on this area here. All right. Whether they should increase production levels. All right. Should I increase the amount of items that I produce and sell to increase profit? This is the key word here, to increase profit. All right. Now, if I go back to that picture in this example 1 here, we know that if our company is at a loss and our costs are outweighing our revenue, we should always increase production to get beyond the break-even point, right? So however many items is in this area here where we're still at a loss because we had our fixed costs that we got compensated for, we always need to increase our production here. But when our company is having a profit, when we're in this area here, which I'm going to use the green for, there are certain quantities of items where I want to increase production There are certain quantities of items where I want to decrease production, even though my company is in a profit state. And this is how we're going to make that decision. We're going to use marginal cost and marginal revenue. I'm going to draw some graphs here, all right? So we're going to have some dollars. We're going to have some quantities here. I'm going to draw two graphs. I'm going to draw a graph here and here. All right. So I'm going to zoom in. All right. So I'm going to zoom in and I'm going to have a graph that looks like this. Okay. And like that. And then I'm going to have a graph. So notice that this top function is steeper than this bottom function, right? I'm going to call this R of Q, and I'm going to call this C of Q. Notice the top function is steeper than the bottom function. I'm zooming in on the special section, okay? And then I'm going to do a similar graph, but here I'm going to have that, and I'm going to have that, right? And what I'm going to do is I'm going to identify a point. I'm going to call this one Q1, and I'm going to call this one here Q2. Notice in this second graph, the top function is still R of Q, and my bottom function is C of Q. All right. This is going to help me determine, and I guess I didn't have to draw this. Okay. It's not the fact that they're so far apart. These two are so far apart is not that important. So I'm going to jot this down. Oh, no, I'm not. Okay. Well, the fact that these two are that far apart is not important necessarily. It can be important, but I'm not focusing on that. What I'm going to focus on is the steepness of these lines. So make sure that this R of Q is steeper than the C of Q here, and then this R of Q is flatter and the C of Q is steeper in this example. The distance between them doesn't matter for now, okay? All right, so in one of these scenarios, I want to increase production. In other scenario, I don't want to increase production, right? We want to always increase production if profit is increasing. And so I'm going to type this out, right? Increase production when profit is increasing. All right. When profit is increasing. All right. Well, when a function is increasing, that means its derivative is positive. That means I'm going to increase production. This, when profit is increasing, is exactly the same as saying when marginal profit, and I'm going to use pi prime of Q, is positive, right? Well, pi prime of Q is R prime of Q minus C prime of Q. So if I'm going to increase production, I want my profit to be increasing. I want my derivative of a profit function to be greater than 0. And since the derivative of profit is the marginal revenue minus the marginal cost, I need to increase production. I'm going to separate these and put the C of Q on the other side by adding C prime of Q on the other side. That means I want to increase production when R prime of Q is greater than C prime of Q. All right. And so if I'm looking at the graph of revenue and cost, and notice in both of these graphs, my company is making a profit because revenue is greater than cost. Revenue function has Y values that are greater than the Y values on my cost function, right? And so in both of these examples, my company is in a profit state. But I only want to increase production in one of these cases. In the case that I want to increase production, right? So if I'm looking at Q1 here, my marginal revenue is the slope of my tangent line at Q1, which is this. My marginal revenue for this function is here, right? In this example, at Q1, R prime of Q1 is greater than, C prime. C prime at Q1, all right? And so, and I know that because the slope of the secant line here is greater than the slope of the secant line there, right? And so what I want to do is I want to increase production. One way I can tell is because R prime of Q is greater than C prime of Q, that means my profit is increasing. And that's why I want to increase production. In this example here, if I do my slope of my tangent lines at Q2, so my slope of my tangent line at Q2 is almost flat here versus at my marginal costs, it is a lot more steeper, right? So here, marginal R prime of Q2 is less than C prime of Q2. And I'm going to say do not increase production. Because in this case, now if I were to continue with this equation or this inequality here, this means if I put that, or if I subtract C prime of Q from both sides here, I'd have R prime minus C prime is less than 0. Remember, your marginal profit is marginal revenue minus marginal cost. So this is basically R prime is pi prime is less than 0. And since this is the derivative of profit, that means your profit is decreasing. All right. Now, remember, we're zooming in on the cases where R is greater than C. And so we're only looking at R is greater than C. There are times where we increase production when C is on top of R, but as I said in this picture above, that's only in this section here before we get to the break-even point. After we get to the break-even point, you only want to increase production if your marginal profit is greater than 0, which means your marginal revenue is greater than your marginal cost. All right, so let's look at an example, and then we'll continue with this one with some examples in class or later. It says cost and revenue functions for a charter bus company are shown in the graph below, right? So our revenue function is that line, our cost function is the nonlinear function. It says for what values of Q will the company make a profit, right? The company makes a profit when marginal revenue is greater than marginal cost, right? Sorry, when regular revenue is greater than regular cost. And so if I look at my function, it starts out with at a loss because my cost is above my revenue. But once I get to this point where Q equals 25, and this point right here where we get like 105 or something like that, it's a little bit bigger than 100, we're going to say that your company makes a profit between Q equals 25 and Q equals 105. All right. It says is marginal cost or marginal revenue greater at Q equals 50? Well, Q equals 50 is here. My line, this is my revenue function, right? It's that linear function. So its tangent line is the line itself. But my cost function is this curvy function. If I draw its tangent line, it looks something like that. It's not as steep as the revenue, right? So I'm going to say that marginal revenue is greater. And so part C says, should the company add the 51st bus? Well, we know that when marginal revenue is greater than marginal cost, we should increase production. And we found that to be true at Q equals 50. And so we're going to say yes, because it will increase profit, right? Or because marginal revenue is greater than marginal cost, which is part B. All right. Now I'm going to go to Q equals 90. Q equals 90 is between 75 and 100. And so it's asking is marginal cost or marginal revenue greater at that value? Well, Q equals 90 is here. The marginal revenue function is this, the tangent line is basically the revenue function. And then at my cost function, let's say that this is 90 here. The tangent line is very steep. It's much more steep compared to the marginal revenue. So here, marginal cost is greater. Okay, I can use the word is greater, the words. And it says, should the company produce or add the 91st bus? Well, when marginal cost is greater than marginal revenue, marginal profit is negative, which means the derivative of a function is negative. That means that function is decreasing. And so we should say no, because profit will decrease. And by knowing the fact that marginal revenue is great, marginal cost is greater, that tells us that profit will decrease. That's all for this video. We'll see you during the next one.